What's good, math family? In today's review, we're going to break down how to use synthetic division to divide polynomial expressions. When we're using synthetic division to divide polynomial expressions, the first thing we want to do is set what we're dividing by equal to 0. So we come in here, x minus 5 equal to 0. We're going to get x is equal to 5. So this is what we're going to be dividing our trinomial by. So now that we know that, we're going to set this up. So we have 5 over here, and then now we're going to write the coefficients of the trinomial. So that's 3, negative 14, negative 5. And then we always bring down the very first term. And now at this step, we multiply and add. So 5 times 3 gives me 15. Negative 14 plus 15 is positive 1. We'll now repeat the process. 5 times 1 gives me a positive 5. Negative 5 plus 5 is 0. And this last number here typically represents the remainder. So because the remainder is 0 here, this means that x minus 5 is a factor for this expression. And now when we talk about expressing the answer typically is always going to be one exponent lower than the original problem. So because this was 3x squared, right? When you divide x squared by x, we're just going to get x. So when we think about our answer, this answer is just 3x plus 1. That's the answer we get once we divide that expression by x minus 5. Now in example number 2, this one is going to be a little bit more tricky because there's more terms for us to deal with, but the process is the same. So we set up what we're dividing by equal to 0. This one is different. It's going to be x is equal to negative 5. So now that we have negative 5, right, we're going to set this up and write the coefficients out. So that means we have positive 2, 12, 6, negative 5, and positive 75. We bring this 2 down. And now we're going to start this process off by multiplying and then adding again. So negative 5 times 2 gives us a negative 10. When we add 12 and negative 10, we get positive 2. We multiply 5 and 2 again to get negative 10. When we add 6 and negative 10, here goes a negative 4. Negative 5 times negative 4 is going to give me a positive 20. Negative 5 plus 20 gives us 15. And when we multiply negative 5 and positive 15, this is going to give us a negative 75. So again, our remainder is 0. So that means that x plus 5 is a factor for this expression. Now when we talk about expressing the final answer, when we look at our exponents, x to the 4th divided by x, that means this is going to start off with x to the 3rd power. So our answer is 2x to the 3rd plus 2x squared minus 4x plus 15. This is the answer that we are going to get once we divide that expression by x plus 5. In our next 3 examples, these problems are going to be a little bit different compared to the first 2, but I'm going to show you how to properly solve and what to do in these situations. So we start off by setting what we're dividing by equal to 0. So we know we're dividing by x is equal to negative 2. So now we could set our problem up. We have negative 2, and then we write our coefficients out, right? 5, 16, 15. Bring our first term down. So now when we multiply negative 2 and 5, we get negative 10. We add 16 and negative 10 to get positive 6. Multiply again, negative 2 and 6 to get negative 12. And we notice something different here. Once we combine 15 and negative 12, we're going to get positive 3. So compared to the first ones, we have a remainder. So what do we do when we have a remainder? Number 1, right, let's start off by writing our answer. We know x squared divided by x is just going to be x to the 1st power. So this problem, right, when we express the answer is going to be 5x plus 6. And with the remainder, what we're going to do is add it to our answer and then put it over what we were dividing by, which was x plus 2. So this would be our answer from dividing that polynomial expression. And when we have a remainder, family, it's important to understand that x plus 2 is not a factor for that trinomial. Now, in example number 2, we're going to notice something a little bit different that we didn't see in the other examples. We have x to the third, x squared, but we do not have an x to the first power. So what do we do when we have a problem like this? So again, we're going to start the process off the same way. What we're dividing by, we're going to set equal to 0. We know we're dividing by x is equal to -3. So now we're going to write out our problem. We have -3, and then we write our coefficients. So we have 2, 7, and then for the x to the first power, anytime we're missing a term like this, we're going to use 0 as a placeholder. So we substitute 0 in, write the rest of the problem. And this works for both synthetic and long division. So now we start the process, right? We multiply -3 and 2 to get -6. When I add 7 and -6, we get +1. Multiply again, 1 and -3 to get -3. 0 plus -3 is the same thing. It's going to stay the same. -3 times -3 is going to give me a +9. And again, when we combine -5 and +9, we're going to get 4 as the remainder. So when we think about expressing our answer, right? We know this is going to start off with x to the second power. So we have 2x squared plus x, right? That's what 1 basically is. It's just x minus 3 and then plus 4. And remember, we're putting it over what we were dividing by, which was x plus 3. So in this problem, again, when we divide 2x to the third plus 7x squared minus 5 by x plus 3, x plus 3 is not a factor or a 0 for that trinomial. We have to be mindful. Now, in our last example of this video, and if the video has been helpful, family, don't forget to smash the like button for us. It really helps us to get this video out to more students. We're going to notice something. We have x to the fifth, x to the third, and x to the first power. So we notice that we're missing x to the fourth and x squared. So when we use those placeholders, those zeros, we're going to use more than 1. And you will see this when you're dealing with this topic. So we start off with what we're dividing by. We're dividing by x is equal to +2. Let's get some more space. So we set our problem up. We have 8. We have no fourth power exponent, so we're going to put 0. Then we go to -6. No x squared term, so that is 0 again. X just represents +1. And then we have -8. So now that we've set the problem up, family, we're able to now go through and start simplifying. So when we multiply, we're going to get 2 times 8, which is 16. 0 plus 16, that stays the same. When I multiply 16 and 2, I'm now going to get 32, right? -6 plus 32 is going to give me 26. We multiply again, 2 times 26 is going to give us 52. 52 is going to stay the same because 0 plus 52, same thing. Now we multiply again. We have 52 times 2, 104. 1 plus 104 is going to give us 105. And then once we multiply again, 105 times 2, what we're going to get is 210. And then from this step, when we add -8 and 210, we're going to get 202. So similar to our other two examples, we also have a remainder. And again, when we look at our exponent powers, we have x to the fifth power divided by x. So we know our answer is going to start off with x to the fourth power. So let's write this out. We have 8x to the fourth plus 16x to the third plus 26x squared plus 52x plus 105. That's our constant. And then we have the plus 202 for our remainder over x minus 2. So when we look at this last example and we divide using synthetic division, this is going to be the answer that we get. We really hope that this review on synthetic division was helpful for you, family. If it was, don't forget to smash the like button for us. Subscribe to the channel and leave comments down below if you guys had questions on this video or if there's topics you guys would like to see on our channel in the future. Thank you guys so much for continuing to watch and support Algebra 1 with Mr. Peters.